My name is Jordan and I'm a product scientist with CriticalPath. This video will discuss CriticalPath's video synchronization feature and how it relates to the barcode and frame counter. When you start a trace recording and launch your instrumented build, a barcode and frame counter will appear in the top left corner. So looking here in the CriticalPath tool, we see when I start the recording, a trace is being recorded, and when the app is launched, the barcode and frame counter appear in the top left-hand corner of the screen. And that occurs when a trace is being recorded for an instrumented app. Let's start with the barcode. The barcode is used to sync the trace file to your screen recording. We parse barcodes during video processing and extract the frame number for each video frame. After uploading your trace file and screen recording to CriticalPath, the screen recording and trace file are automatically cropped and synchronized. This is why you wait a moment for your video to process after uploading. Once your trace file is synced with the recording, the current time indicator is used to scrub through the recording and trace file to see what processes occur within the app as the recording progresses and the UI updates. So looking in the CriticalPath tool, this blue flag here is the current time indicator, and as I move the flag across the timeline, the video progresses forwards and then backwards if I go in the opposite direction. And if I press the play button here in the video panel, that will automatically move the current time indicator across the timeline. And I can also play the video recording at 50% speed here, so the current time indicator will move more slowly across the timeline. And I can also loop the recording here if I select this icon. Now I'll discuss the frame counter. The frame counter helps to keep track of the UI updates as they occur frame by frame, so that when analyzing the screen recording, it is apparent at which frame a UI update occurred. The frame counter goes hand in hand with the frames thread on the trace file, which shows the processes that occur during each frame. So for example here, I'll just pick a random frame. I'll pick this frame here. This is frame 419. So we see the frame starts here, and this is where frame 418 begins, and the frame ends here. And this is where frame 420 begins. And then we can see, looking in this region of F419, which is frame 419, that it's the same frame that's being shown on the screen right here. And we also see all of these slices, which are the processes or functions that are executing while frame 419 is being shown on the screen. These are all the slices that are executing in the main thread while frame 419 is being shown. And I can also see the slices that are executing in parallel threads during this time as well. And you may notice that frame 419 is red. And if I zoom out, you can see that other frames are red as well. CriticalPath automatically highlights the red frames, and the red frames are slower frames, which are frames that take longer to render. And these frames should be avoided when trying to create a smooth UX, especially when there is an animation that is happening or when the user is scrolling. So we see here, this frame is taking longer to render, the animation is starting, but we see the exact processes and functions that are executing while this frame is being shown on the screen. In addition to the frames thread, each choreographer slice is also associated with its own frame number. So we see here, if I zoom into this choreographer slice, this choreographer is associated with frame 20. And because choreographers are responsible for managing the animations, transitions, and rendering operations on the device screen, that actually means that this choreographer is responsible for rendering frame 420 on the screen. So that's why this choreographer occurs right before frame 20, because it's rendering the frame, and then this is when the screen updates and we see it. And again, each choreographer is associated with a frame. So if I go to the next frame, frame 421 is associated with this choreographer because it goes in order frame by frame. And that means that this choreographer is responsible for rendering frame 421, which we see on the recording here. And then lastly, I can actually select the choreographer slice that's associated with the frame. So in this case, frame 420. And if I select this choreographer slice, I then see the execution path, which shows all of the processes and functions that were called that led to this frame being shown on the screen. And for additional detail about the main execution path and how all of that works, we have a dedicated video on the CriticalPath website. Thus, to put everything together, you can find the UI update and the frame number for when it occurs using the video feature, and then you can go to the frames thread in CriticalPath to see the processes and functions that were executing within the app's code while that frame and UI update was occurring on the screen. And you can also find the corresponding choreographer slice and select it to reveal the execution path and see the progression of calls that were made and the different processes that were executed in order to show that frame on the screen or render a particular UI update. And this visibility is extremely helpful when trying to diagnose and remedy UI-related performance issues. That concludes this video about CriticalPath's video synchronization, barcode, and frame counter. And for more information about CriticalPath, feel free to check out any of the other videos on our site.